7, we will be switching gears a little bit, and instead of solving equations, we'll be solving inequalities. So what kind of inequalities are you going to have to take care of? Well, you'll just have regular linear inequalities. You will also have compound inequalities where you have more than one inequality sign. And then you also have quadratic, maybe even some rational inequalities to go with them. And so these will be the types of inequalities you're going to have to work with. A couple things here. Number one, properties of inequalities. Well, the number one property of inequalities, you've learned this ever since you were like in pre-algebra, and that is if you multiply or divide by a negative number, okay, you need to switch the inequality sign. So if you had greater than, it would become less than. If you had less than or equal to, it would become greater than or equal to. And that's the number one property that you're going to need to keep in mind today. We've got some special cases here. When we have quadratic or rational inequalities, some things are going to happen. You're going to get multiple answers. And what do these multiple answers mean? Okay, well, let's say we had something like x equals negative 2 and 5. Okay, well, these actually aren't our answers, since they're inequalities. They're going to be intervals. And so what will happen is you'll draw yourself a little number line. So 1, 2, 3, negative 2. We'll go 1, 2, 3, 4, 5. Okay, and so if negative 2 and 5 were the kind of the solutions I came up with, okay, well, my intervals would be, there's everything less than negative 2. There's the stuff in between negative 2 and 5, and then there's the stuff that's greater than 5. And you're going to pick test points for each one of these intervals, and they're either going to be true or false. So if I pick, all right, negative 3, 0 would be a good test point, maybe 10, I don't know, pick numbers that are going to be easy for you to work with, but you're going to plug these test cases back into your original inequality, and it'll either be true or false. And if it's true, well, then that means, it would be kind of everything to the left here. And if it were false, well, then that doesn't work. And so solutions wouldn't be here. And, probably this one would be true, and then you'd have everything to the right. Okay? And so this is going to be your strategy when you have quadratic or rational inequalities. So you'll have multiple answers. So these are the intervals that we're talking about. We also have kind of a new notation, which we're going to put here. It's a little bit weird. Basically, if for this, if you think about like this interval notation, well, I guess here we'll start with the graphing stuff. You're probably used to like open dot. Well, here, instead of open dot, we're going to do kind of a curvy line. And if you have or equal to, you're probably used to that being a filled in dot. Well, that's going to be the bracket. Otherwise, it's exactly the same. If it's just straight, like greater than or equal to, it'll just go on forever to the right with an arrow. Okay, interval notation. This one, again, is a little bit tricky. It's just different, different thing to remember. So, if we have x is greater than 5, okay, well, 5 is the thing that we're going to put here, and then greater than goes forever to the right. And so that's why we see kind of infinity going to the right. And then if we were going to the left, we'd have negative infinity going to the left, and we'd have our answer here. So that's kind of how it goes. And then Of course, if we have it in between, we have an end on the left and an end on the right. So there you go. No infinities. All right, well, you can read through this and kind of make the connections yourself. It's not all that crazy. When we have or equal to, said that's a bracket. So if we go to interval notation, we also have a bracket. But if it's regular less than, well, then we have a parentheses. I think we've got another one over here, kind of very similar thing. All right, let's get to some example problems. Well, here would just be a regular old inequality. First thing, we'll treat it just like a regular equation. We would subtract -5 from both sides. Now I got -3 is greater than -12, and I guess 3x. So here I divide both sides by -3. I remember my rule that, well, when I divide by a negative, I'm going to switch greater than to less than, and then I've got 4. Okay, if I were going to put this in interval notation, it would be parentheses, and then because it's less than, I'm going forever to the left. So negative infinity, and then just positive 4. All right, over here, kind of the same deal. We'll go ahead and I typically try to put all my x's on the left, even if it gives me a negative number. So I got 4 minus 5x is less than or equal to 7. Now I'm subtracting 4 from both sides, and I've got -5x less than or equal to 3. Divide both sides by -5. Nope. Dividing by a negative, we're going to switch the sign again. So x becomes greater than or equal to -3/5. Okay, if I were to put this into that interval notation, I would have the hard bracket on the left, -3/5 here, and then I go forever to the right, so infinity here, and that's going to be a smooth bracket. So anytime you've got infinity, that's going to be a smooth bracket, but if you've got the or equal to, that's going to be the hard bracket. All right, moving on to the next slide. We're cruising. Here we've got a compound inequality. I've got more than one inequality symbol. So typically what I might do here is I'd just break it up. It's easier for me to think of it that way. Not that you have to, but again, it's a little easier for me, at least, to see it out. So I've got -2 is less than 5 plus 3x, and I've also got 5 plus 3x is less than 20. All right, well, again, I can just treat these like pretty simple inequalities. Now I've got -7 is less than 3x. Be careful, especially when your x is on the right-hand side here, that you don't accidentally just flip it over there without flipping the sign. So we're dividing both sides by 3, so I got -7/3. And there we go. So -7/3 is less than x, or x is greater than -7/3. Over here, I'm going to similarly subtract 5 from both sides. Now I've got 3x is less than 15. Divide both sides by 3, and x is less than 5. Okay, so my final answer, kind of mush them all back together. I want x to be less than 5. And I also want x to be greater than -7/3. If I were to put this in interval notation, if I'm greater than, it's stuff on the left, and then the stuff on the right would be the maximum. And since these are both just strictly, or I guess, less than, I'm going to have the smooth brackets. Okay, moving on. Here is our example of a quadratic. All right, well, the quadratic's not going to be altogether that much excitement. So we've got it equal to 0. We're going to factor it. We've got x. We know we're going to have one positive, one negative. Factors of 12 that give me -1. Be +3 and -4. And so kind of my tentative starting solutions here, x being -3 and +4. But remember, this is mostly just an interval, okay? So we're definitely not done yet, okay? It's not like -3 and 4 make these true. So here's what's going to happen. We'll go ahead and start our number line. We'll go negative 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Okay. So our spots here are that make our intervals. We've got negative 3, so that's going to be right around here. And then I've got 4, which is right around here. So I'm going to pick a test point that's in each one of my intervals. I can pick anything over here. Maybe negative 4 would work. So I'm going to pick negative 4 as a test point. Obviously 0 is a good one to test. 5 seems like it'd be nice to test. Okay, so I'm going to plug these into this, and I'm going to see what I get. It's either going to be true or false. Can't be both. So let's see, I've got negative 4 squared is positive 16, minus negative 4, so plus 4, minus 12. How is this related to 0? Well, leaves 20 minus 12 is 8. Is 8 less than 0? Nope. So this is not part of my solution. If I plug in 0, how does that work out? Well, let's see, 0 squared is 0. Minus 0, minus 12. Is this less than 0? Is negative 12 less than 0? Yep, that's true. And so this one checks out. This is going to be good. I'm probably going to imagine that this one isn't going to work, but I'll check it anyway. 5 squared is 25. Minus 5, minus 12. How is this related to 0? Well, see, I got, 20 minus 12 is 8. Is 8 less than 0? No. And so this one doesn't work either. Okay, my solutions are going to be the things on the inside here. Okay, and of course this is going to be a smooth bracket here, and it'd be everything on the inside. So if I were to write my solutions, I'd say, all right, x is going to be in between negative 3 and positive 4. If I put it in interval notation, again, it's going to have smooth brackets. And there it is. Okay, continuing to move on. We've got one more, and here's your rational inequality. Now, your first instinct will probably be to go ahead and multiply both sides by 3x plus 4. But, quick question. What if 3x plus 4 is negative? What if it were positive? Well, we would have two different solutions, right? Depending on what x is, x could make this whole denominator either positive or negative. And so it would have two different kind of solutions. So we've got a way around that. And here's what we're going to do. We're going to just put everything on the left-hand side. And that will give us 2x minus 1 over 3x plus 4 minus 5 is less than 0. Now we're going to essentially kind of work all of this down. So I'll just keep 2x minus 1 over 3x plus 4. My common denominator between these two things would be 3x minus 4. So I'd have 3x minus 4 on top and 3x minus 4 on bottom. And as I go ahead and solve this, I have 2x minus 1 minus 15x plus 20 over 3x minus 4 is less than 0. And when I combine all of my like terms, I'm going to get negative 13x minus 21 over 3x minus 4 is less than 0. Okay, so like we did with the quadratic, we're going to want to find our intervals. And in this case, our intervals are going to be a little bit different in how we find them. Okay, I'm going to want to go ahead and figure out, well, when is my numerator equal to 0? And when is my denominator equal to 0? When my numerator is equal to 0, then the whole thing is equal to 0. When my denominator is equal to 0, I don't have any solution. So that's kind of the thought process behind it. So I've got negative 13x minus 21. When is this equal to 0? And then I also have 3x minus 4. When is this equal to 0? This is going to give me my interval. So I got negative 13x equals 21. And so x is going to equal negative 21 over 13. So here's one of my intervals. That's an unfortunate interval. Over here, I just add 4. So I got 3x equals 4. And so x equals 4/3. All right, we've got our spots that make our interval. And so let's now go ahead and kind of set up that, that number line. Okay, so looks like oh, this was 3x plus 4, wasn't it? Sorry, 3x plus 4. I made a mistake, sorry. So 3x plus 4 is going over here. How does that change things? I'd have still minus 20x. Okay, and so that's how I got minus 21. All right, but then, of course, down here, I still have 3x plus 4. Okay, so that would change this to 3x plus 4, making this negative 4, making this negative 4/3. All right, well, it looks like everything's happening to the left of 0. And so let's spread this out a little bit. We'll make negative 1, negative 2, and negative 3. All right, well, negative 21/3. Negative 21/3, I'd say that would be just a touch under negative 2. And negative 4/3, that would just be a touch over negative 1. So here's my intervals. I want to pick convenient numbers for myself. So I don't know, let's go with negative 3. Let's go with negative 1.5. There's nothing really good there. And of course, let's pick 0. Okay, so if I go ahead and throw negative 3 back into this, I get negative 6 minus 1, which is negative 7, over, well, 3 times negative 3 is negative 9. Negative 9 plus 4 is negative 5. Okay, so I get positive 7/5. Is this less than 5? Well, and the answer to that is yes, that's true. And so negative 3 is a solution. This works out. All right, if I go ahead and plug in negative 1.5, well, 2 times negative 1.5, that's going to be negative 3 minus 1, which is negative 4. And then if I plug in negative 1.5 here, I'm going to get negative 1/2. And so I wind up getting 8. Is 8 less than 5? No. And so this one right here at negative 1.5 just doesn't work out, which we didn't really expect it to. And then over here, picking 0. 0 is going to be a nice friendly one to work with. 2 times 0 is 0, minus 1 is negative 1. On the bottom, I get 0 plus 4, which is 4. Is negative 1/4 less than 5? I'd say yes. Okay, and so this one checks out. And so we would have kind of our smooth bracket here go in this direction, and our smooth bracket here go in that direction. And I guess how would we write it? So I would probably say just x is less than negative 21/13, or x is greater than negative 4/3. Okay, why would I say or instead of and? Well, because it's or. The interval way is, well, we got two things to write. We go forever to the left, so negative infinity, and then negative 21/13 here. And then, oh, instead of or, we would write the union. So, and then x over here would just kind of be negative 4/3, And we're going up to infinity.